Alright, Assalamualaikum warahmatullahi wabarakatuh, and a very good afternoon, I bet to everyone. Yeah, so today we are going to continue our chapter 5.1 gas. So last week I have explained about I've introduced you what is kinetic molecular theory of gases, the Charles law, Boyle's law, Avogadro's law, the combined gas law, the ideal gas equation, the Dalton's law, the partial pressure. So today we are going to look at the deviation from ideal gas behavior. So the difference between the ideal gas versus the real gas. Alright, so here, if you look at this, it says that the ideal gas is the gases which obey the ideal gas equation. So which means that the ideal gas obeys the Boyle's law, the Charles law, and the Avogadro's law. They are the perfect gas. Okay, however, the real gas is the gases which do not obey ideal gas equation, or we can also known as the non-ideal gas. Okay. However, the real gas can also behave ideally when it is at low pressure and high temperature. So basically, if the gas is at low pressure and high temperature, the real gas will approach the behavior of an ideal gas. Alright? So what's the difference between ideal gas and real gas behavior? So the first thing, the ideal gas, the molecules of the gas has negligible volume. So the volume of the gas molecules for an ideal gas is not significant. However, for the real gas, the molecules of the gas do occupy some space, and it depends on the size of atoms and the bond length, which means that in real gas, the molecule of the gas has a significant volume. Alright. Next, we go to the next part. The ideal gas does not have intermolecular forces, which means that the molecule of the gas do not attract or repulse with one another, which means that the intermolecular forces of the gas molecules in the ideal gas is negligible, is not significant. However, in the real gas, there are attractive and repulsive forces among the molecules, which means that there is an intermolecular interaction between the gas molecule, and the intermolecular interaction is significant. So, for the formula, the ideal gas equation obey the ideal gas equation. The ideal gas obey the ideal gas equation, which is PV is equals to nRT. However, the real gas obey the van der Waals equation, where there are some corrections added into the ideal gas equation to correct the pressure and the volume of the real gas. So we are going to look at what is van der Waals forces equation after this. Okay? So, reminder that real gas can behave ideally at the low pressure and the high temperature condition. Okay? So, let's look at how real gas behaved as an ideal gas. Okay. So, gas will behave almost ideally at very low pressure. So, when you lower the pressure, you can increase the volume. So, when the volume increase, the gas molecules will be further apart from each other. So when the gas molecules are far apart from each other, the intermolecular forces will be not significant, will be negligible. And then the volume of gas molecule will be negligible as well. So this will obey the kinetic molecular theory of gases, where the gas will behave ideally. Okay. Right. Oops, why does it not? Okay. Alright. The gas can also behave almost ideally at a very high temperature. So when the gas has a very high temperature, it has the kinetic energy. They move faster. So when the kinetic energy high, they are free from attractive force because they move faster than usual. So dia tak ada masa nak ada attractive force between the gas molecule. So the intermolecular forces is negligible, and this will make the real gas obey the kinetic molecular theory of gas. And it says that the real gas will then behave ideally. Okay, so remember, there are two conditions where the real gas will behave ideally. First, when the real gas is at the low pressure, and the second one is when the gas is at the very high temperature. So bear in your mind that two condition. Okay, all right. So next, okay, what is the behavior of the non-ideal gas or the real gas? The behavior of the real gas. Okay, so the real gas or the non-ideal gas, they behave deviates from the ideal gas behavior when they are at the high pressure. Okay, so when they're at high pressure, the volume of the container is reduced. So when the volume of the container is reduced, the distance between the gas molecules are getting closer. Yalah, bila makin kecil space dia, dia punya distance between the gas molecule makin dekat, getting closer. So when the distance between the gas molecules getting closer, the intermolecular forces attraction now become significant. Dia dah tak boleh hiraukan dia punya intermolecular forces, because bila the gas molecules become closer towards each other, there will be the attraction and repulsion between the gas molecule. So now the ideal gas has deviated from the ideal gas behavior, so it become the real gas now. Okay. The second condition is when at low temperature. So when at lower temperature, the kinetic energy of the molecule decreases. So the molecule, they move slower and slower and slower, and they tend to become closer towards each other as well. So by that means there is attractive forces between the gas molecules. So now the attractive forces become significant. So now they are deviate from the ideal gas behavior. So the gas behave as a real gas. Okay, so just now we say that the real gas, they obey the van der Waals equation. So what is van der Waals equation? So van der Waals equation is used to describe the real gas behavior at the condition where there is a high pressure and a low temperature. So remember, at high pressure and low temperature, the gas will behave as a real gas. So this van der Waals equation is modified from the ideal gas equation, which we consider the derivation of the real gas. So when the gas behaves as a real gas, the pressure of the real gas is actually less than the pressure of the real gas. Okay, why? Okay, when there is the intermolecular forces between the gas molecule just now, it means that the gas molecule moves slower, right? Move slower. That's why the punya what we call it, intermolecular forces become significant. So bila dia move slower, dia dah give less impact. Dia dah tak ada macam collision between the what we call it, between the wall of the container ke apa. So bila dia move slowly, dia dah tak ada more collision dengan gas, dengan wall of the container. So maksudnya pressure dia pun makin berkurang. That's why we say the pressure for the real gas is lower than the pressure of an ideal gas. Okay, Ketika sini pula, the volume of real gas is larger than the volume of ideal gas. Okay. Untuk ideal gas, we assume that the volume of the gas particles is negligible compared to the volume of the container. Okay, but in reality, in real gas, the gas particle actually they occupy a certain amount of volume in the container. So the volume of the real gas is actually larger than what we expect from the ideal gas. So it's particularly significant here in the real gas. So that is why we say that the volume of the real gas is larger than the volume of the ideal gas. So to make a correction for the in the ideal gas equation, so that we can describe the real gas behavior, we put a correction term at the pressure and the volume. So dekat sini we have so asalnya for the ideal gas equation it is PV equals to nRT, but here since we see that the pressure of real gas is less than ideal gas, the pressure of real gas is less than the ideal gas and the volume of real gas is larger than the ideal gas, we make some we put some correction term at the pressure and the volume to correct the what we call it, to macam correct the fact that actually the pressure of the real gas is smaller than the pressure of ideal gas, and to correct for the fact that the volume of the real gas is actually larger than the volume of ideal gas. So here, so this is what we call the pressure correction term, and this is what we call the volume correction term. So the A is a constant which correct the attractive forces between the gas molecule. Okay, so and B is the constant which correct the volume of gas molecule. Okay, listen carefully. So what I mean by that, so this A is the constant that correct the what we call it, that correct for the intermolecular forces kan. So maksudnya if the value of A is bigger, it means that they have stronger attractive forces. So when it has a stronger attractive forces, the interaction or the interaction between the gas molecules become significant. So that's mean the gas will behave as a real gas. Okay. For the B, so B is the gas is the constant that corrects the volume of the gas molecule. So by having said that, when B is smaller, that means the volume or the gas molecule occupied what we call it, the volume occupied by the gas molecule is also small. So by that we can say that the volume of the gas the volume occupied by the gas molecule is not significant. So bila B dia smaller, the volume occupied is not significant. So that's mean the gas behave ideally. Itu je beza dia. So remember Okay. So let's see the explanation. Why the pressure of real gas is less than the pressure of ideal gas. So in real gas, the attractive forces slow down the movement of molecule. So there will be less collision with the wall. So bila ada less collision with the wall, dia ada low pressure exerted compared to the ideal gas situation. So that's mean larger values of A. So the larger value of A indicate strong attractive forces. So bila ada strong attractive forces, dia punya interaction between the gas molecule becomes significant. Hence, the gas will behave more like a real gas compared to an ideal gas. Okay. So it says that the volume of the real gas is larger than the ideal gas. So here the V ideal is equals to the V real minus NB. So it means that when the B value is large, so that means the volume occupied by the gas molecule is bigger. So bila bigger, the volume occupied by the gas molecule becomes significant. So the gas will behave more like a real gas compared to the ideal gas. Okay? So senang cerita bila A dengan B larger, dia punya gas tu will tend to behave more like a real gas compared to an ideal gas. Alright. So if you look at this, the van der Waals equation is combining both factors into the ideal gas equation. So tadi ada dua factors kan? The factors of intermolecular forces and the factors of the volume. So here, when we combine these factors, we will get the van der Waals equation P plus n squared A over V squared times dengan V minus NB equals to nRT. So this is what we call the van der Waals equation. Okay, so now it's quiz time. So what are you going to do in this quiz time? Okay, pause this and then you need to read the question, choose the correct answer, and then you need to state your answer for this question by commenting in the comment section below. So look at the first question. Dia kata, in the van der Waals equation, the factor n squared A over V squared act as the pressure correction term to correct for the fact that the pressure of the real gas is less than the pressure of the ideal gas. And the A value here indicates the attractive forces between the gas molecule. Question 1. So the smaller the A value, so pilihlah jawapan, choose the correct answer. I have explained to you many times, so apa jawapan dia? Okay, so yeah, take your time, pause this video and answer the question. So this is actually the first part of the lecture video. The second part of the lecture video for this week is about 5.2 liquid. So stay tuned, okay? Alright, thank you. Bye. Assalamualaikum. See you in the second part of the video.